All right, boys and girls. We're going to work on the solutions to problems 1, 2, and 3 uh, on this worksheet entitled Dimensional Analysis Worksheet. Just take a quick look here. Up at the top, they tell us that a mile is 5,280 feet, 1 inch is 2.54 centimeters, etc., etc. These are what are known as conversion factors. And conversion factors are so important to doing dimensional analysis problems. Matter of fact, so much so that I had also given you a link to a very much larger list of conversion factors. Matter of fact, if you print this out, I would at the top label this as conversion factors. Right? Conversion factors are just a set of numbers that equate one unit of measurement with another. For example, at the top, 1 foot is equal to 12 inches. And that same 1 foot or 12 inches is also equal to 0.3048 meters. All right, there's, let's see, under volume, a gallon, a U.S. gallon is 231 cubic inches. All right, a quart, 0.9464 liters, etc. And there's a second page to it too. That includes units of power and units of time. Right? Keep these next to you. We may be using them for these problems. Anyway, the main problem type we're going to run into when doing dimensional analysis type of calculations. Dimensional analysis is just a particular method of doing solutions to certain types of problems. The type of problem we often run into where dimensional analysis is helpful is problems like we see here, where we're asked to take one measurement and just convert it into a different set of units. So in number 1, 5,400 inches. What is that same measurement in miles? All right. 5,400 inches might be, if you were in the high school, the distance, say, from Shawnee Ave in the back of the school all the way out to Route 11 in the front of the school. Right? That's 5,400 inches, let's just say. I simply want to say, okay, what is that same measurement but described in miles? Right? What we need to do here is utilize conversion factors. We know that there are a certain number of inches in a foot and that there's a certain number of feet in the mile. So if I use those numbers properly, I could make this conversion easily. The real crux of the problem, though, of this solution is how do I set up my equation so that I do this properly? And let's do it. Let's just jump right in. Let's go back a second and give ourselves just a generalized equation. We always begin our equation with the given. In this case, it's the 5,400 inches. And then we multiply it by some number over some other number. And this ratio of numbers is, in fact, a conversion factor. Like 12 inches over 1 foot, or let's say 3 feet is 1 yard, or 5,280 feet is 1 mile. You know, any conversion factor that we happen to need to utilize, any of these would go here. All right. Like I said, like 1 foot is 12 inches. All right. One number over another. It's a conversion factor. Now, we may need to use multiple conversion factors, so we might need to go and do this again, where we have another pair of numbers A, B, which represent just another conversion factor. Right? And this may continue on. Right? And at some point, we will be done setting this equation up, and we could put an equal sign in and then go through the solution part of it. Okay. So this is the general setup. The general setup for dimensional analysis. All right, so in our first problem, the given is 5,400 inches. All right, I'll get rid of that comma. We now want to multiply it by a conversion factor that's going to help us get to miles. All right. Well, I don't have a set of numbers that relate inches to miles directly, but I do have a conversion factor that tells me 12 inches equals 1 foot. Right? I know that. Right? So if I set this up properly, I could go from inches to feet. Right? And that's exactly what I'm going to do. Right? Stay with me here a little bit. Okay. I'm going to set this up so that the 1 foot part of that conversion factor is going to be on top and the 12 inches are on bottom. It's possible for me to flip that over and have 12 inches on top and 1 foot on bottom, but in this instance, it's not what I want to do. The driving force behind your decision to put feet over inches, not inches over feet, is what I'm simply going to refer to as cancellation of units. Right. Each one of these conversion factors, every one of these conversion factors that you're going to stick in this equation after you write down the given, are all going to be set up with one intent, and that is at each step you want to cancel units. What do I mean by cancel units? Well, if you look closely, you will see that right up here, the given has units of inches. Now, I don't want inches in my answer. I want miles. I know we'll get to miles, but I certainly don't want inches. So looking just at the units of this measurement, I say to myself, I want to get rid of those units. And if you notice down here, because I set up my conversion factor 1 foot over 12 inches, the inches on this factor are down in the bottom. And up here, the inches are on top. All right. Now, this sort of is the same kind of idea of cancellation when we're multiplying fractions. Just as an example, 3/2 times 7/3. If I wanted to get an answer to this, I could say easily, well, the 3 on top cancels with the 3 on bottom. I could simplify that and simply get 7/2 as my answer. Well, just like you could cancel common factors, 1 on top with 1 on bottom, that's the same. We take that same idea and extend it and say a unit that's on top can cancel with a similar unit that's down on bottom. So in this case, my inches cancel, and I'm left with feet. All right. But I don't want feet in my answer. I want miles. So I'm going to go further down here and add another conversion factor. And this one's going to have feet on bottom and miles on top. Now, why do I set it up with feet on bottom and miles on top? The driving urge that you have in doing all of this work is cancellation of units. At each step in the process, that's what's in the back of your mind. Cancel my units, cancel my units, cancel my units, and stop when you get to the unit you're asked for in the problem. I'm asked for miles in this question. So I start with inches. I want to get rid of inches, but here it left me with feet. Well, then let's get rid of feet. Feet on bottom cancels with feet on top, and I'd be left with miles. Now the only real issue is what numbers go here. All right. Well, remember, each one of these ratios is a conversion factor. And if I pull up my conversion factors, right here, the second line says 1 mile equals so many yards. I don't want that one. But the next one says 1 mile is 5,280 feet. That's the one I want. Right? 1 mile is 5,280 feet. All right. Again, the feet units here cancel with the feet units here. And the only unit, all right, it's not the numbers, it's the unit. The only unit that I still have left is miles. So that means I'm done. I wanted miles. Look back at the problem. It says 5,400 inches is how many miles? I've got miles. I was able to start with inches, and through, setting up conversion factors properly, I ended up just with miles by canceling everything I don't need. So now it's time for me to put an equal sign after this equation and just say, okay, whatever my answer here is going to have units of miles. Now, what about the front? What about the number that goes in front of miles? Well, the number that we get to go with miles, let me just do some erasing here. Let me just ignore these units for a second. What I'm left with now here is really one number multiplied by another multiplied by another. Now, these last two numbers are in fractional form. Let me take the 5,400 and also put that in fractional form. Remember, you could take any number and put it over 1 and create a fraction out of it. 5,400 is the same as 5,400 over 1. Anyway, you have one fraction multiplied by another fraction multiplied by another fraction. All right? So you do this arithmetic here, and that's the number that's going to be put in front of miles. Now, how do we multiply these fractions together? We multiply all the numerators together. 5,400 times 1 times 1 is simply going to be 5,400. Now, what's the bottom? 1 times 12 times 5,280. Well, I'm going to need a calculator for that. All right. 1 times 12 times 5,280 equals 63,360. All right. And then that would be units of miles. Now, I am not going to leave this in fractional form. I'm going to actually do this as a division problem. So I'll clear out my calculator. 5,400 divided by 63,360 is equal to 0.085227, and then a whole bunch more numbers, and then that's miles. Now, the very last little bit is we have to invoke our rules for significant digits. How many of these digits in the answer should we be writing down? Okay, if you haven't written this, well, I'm sure you haven't written this down in your notes, but let's write it down now. The number of sig digs in your answer will be equal to the number of sig digs in the given. The number of sig digs in your answer, this number right here, will be equal to the number of sig digs in the given. Remember, the given is the bit of information that you're presented with in the problem. 5,400 is the given in this case. How many sig digs in that number? Well, if you say 4, you're wrong. It's only 2. These last two zeros are only placeholders. They're not significant. 2 sig digs here mean I want only 2 in my answer. So if I round my answer to 2 sig digs, that means I need to chop off the 227 because the 8 and the 5 are the first 2 sig digs. Now, if I'm chopping off a 2 here, that means I'm going to round down. So the answer will simply be, right of this, equals 0.085 miles. All right. So if I said to you earlier that 5,400 inches is the distance from Shawnee Ave down to Route 11, Main Street, and the school, that is equal to a distance of 0.085 miles. If you round this again up to the tenths place, that's about a tenth of a mile. If you're familiar with the odometer readings in a car, they count the miles by tenths of miles. So if the number on your odometer changes by one digit, that's a tenth of a mile. So that's about right, is best of the guesses I could make.